Today we're going to look at why you as a DevOps engineer or as a software engineer, why do you need observability in your CICD pipeline? We're going to look at some details around the OpenTelemetry Special Interest Group that we already covered on this channel, but today we're going to look into more details around that. We're going to see some live presentations of the stuff that we're actually looking at for NEXO Share, and I hope that I'm going to answer some of the questions that you might have on why CICD in your observability in your CICD pipeline is important. And before we get too technical, we're going to start with an analogy, and we see on the left-hand side of the screen, we see a farmer that is planting every seed of what he wants to grow later, which is going to be corn. He's planting it every single seed is being planted, and he's plants it by hand, and he's actually looking at how the different plants grow, and then he also waters them by hand, and he really takes care of every single plant. And on the right hand side we see a farmer that has a lot of land and actually has a lot of things to plant, and does not have the time to focus on every single plant. It does not have the time to observe and look how the plants grow. Which is with that, also he obviously doesn't see if there is a problem within the plant. So the corn plants get bigger and bigger, and at the end what we see on the left hand side is that the farmer that has been taking care a lot of every single corn has grown very successfully. On the farmer on the right hand side has had a few challenges with his corn. And yes, while we are exaggerating a little bit, this analogy should show us how important it is also to look at how things grow and how things become available. And in software industry, this, at least for me, it means how does the software that we build, the code that we package, how does that get to our production environment where our customers are actually going to work on it and are going to hit it? And I think that's what we call our continuous integration, continuous deployment pipeline. And that's what we're going to look at today. We're going to look at why do we need observability in our CI/CD pipelines. And this is a talk that I've been giving at a CLC conference in Mannheim in November 2025. And I'm going to use the slides from that talk and then later look at a little bit into into the stuff that we do for NEXO Share today. The problem that we're going to look at is very similar to the farmer problem. We have a lot of observability nowadays for the applications that we create. We know how to do traces, look at log files, look at metrics from the application that is up and running in our production environment, because the moment that something is down, like the status pages and stuff like that, we need to get an alert on that, but we never really look into the details around how the application is created, shipped, and also made available. And that's what we're trying to do in this initiative. And if I look back at how I started my career, in automated testing, and one of the first things that I did look at every morning was something that we called the Nachtcompile, which was a process that at the time ran once per day and compiled our on-premise software for all different kind of flavors. And it tested the main branch, the trunk or branch of the code base that we have, and executed some tests. We then got an HTML page out of that, and we looked into the results, but we did not really have much insights into the steps that run in between. We only looked at the timing for the test in general. We looked at the log files of the test in general, and that still helped us to identify a lot of problems. Today's world is a little bit different, and it is more important than ever to look into the details of the software development lifecycle. So the agenda that we're going to cover today is going to follow this. We're going to start with some definitions, then we're going to look at OpenTelemetry as a CNCF project, and from there we are going to look into details. Why do we actually need to observe our pipelines? And then from there we are going to talk about the OpenTelemetry Special Interest Group that we have, and this is going to drive most of the conversation. But before we do that, let's do some terms and definitions. So first one is CI and CD, and I think we don't argue about what CI means. CI means continuous integration. We might start to argue what continuous delivery CD is, because it can be continuous delivery. It can also be continuous deployment. If for our talk today, we're going to look at using the continuous deployment term. Continuous deployment means the moment that you push something on a main branch, that very moment that code is directly pushed up to production. And that also means that stuff that we are building does not always directly be active, right? So it become active. So sometimes there is a feature flag that hides some functionality from some users or from all users. But in general, the context is you push to the main branch and it directly gets deployed automatically. Now, Gregor, who is a very well-known architect, recently said, okay, we don't want to do CICD anymore. That's like boring. We're going to just say CD, which means continuous deployment in his case, right? Because in 2025, you cannot do CD without CI, right? So it's like a duplicated term. It's talking about CD implies that you already have CI. And I think that's something that I'm also trying to advocate on my channel for a little while already. As a next step, we're going to try to document what observability is. And observability, the way that I look at that and the way that Wikipedia defines that, is the ability to collect data about programs execution, modules, internal states, and the communication among components. What does that mean? It means that essentially from outside you look into the application, the module, or whatever is running, and you try to observe the state and you try to look at what's actually happening. And this is usually a combination of log files, metrics, and traces. Log files being the funny stuff where you do console log or output any kind of information into the text log. Metrics being CPU usage consumption, the numbers of times that you're going through a cycle, numbers of executions, whatever, right? Traces then being the first thing that actually gives us insight into the up and running application. So log files and metrics helps us to, after something happened, understand what happened. Traces give us the possibility to kind of look in real time into what's going on within an application. So this means it collects every single span, every single action that is happening within your application. And this is the way that OpenTelemetry also defines the concept of observability. And we're going to look a little bit more into that in the future. Next definition that we're looking at is the CNCF. The Cloud Native Computing Foundation is part of the Linux Foundation. It's an organization that also hosts the Kubernetes project and gives governance around open source project. It helps to streamline the development processes and to keep the focus and to ensure that the definitions and the things that are being defined within the ecosystem also follow some standards and conventions and is then being adapted by some of the vendors. And if you look at the landscape of the CNCF today, and for those that are part of the CNCF or are working as part of the CNCF, you know this landscape, right? It's pretty big. There's hundreds of different tools and things going on in there, right? There's different sections. Up here we have the projects and product section. Within the projects and product section, we then have a definition. We then have a few other things going on, right? And then down here there is the observability tab, and the landscape we are working on is essentially the observability stack, and there's a lot of different projects in that part of the landscape, and one that we're going to look at today is going to be the OpenTelemetry one, right? And this is the project puts itself as defining high quality, ambiguous, and portable telemetry to enable effective observability. This essentially means being a collection of APIs, SDKs, and tools that help us to instrument, generate, collect, and export telemetry data. And this means collecting exactly what we looked at before, like logs, metrics, and traces in the standard way, so it can be adapted by multiple vendors. And it then gives us the possibility to be vendor agnostic when actually working with the data that is being collected. Last definition that we're going to do is the special interest group. That's the SIG, right? This is within a CNCF project. That's a group of people that is interested in a specific thing. And in our case, the specific thing that we're looking at is CD, right? So how do we observe, how do we look at the process that we call CD, or the combination of CI pipeline and then deployment of our application. Now, we're done with our terms and definitions. Now let's have a look on why do we need observability in our CI/CD pipelines. So why do we want to why do we need observability in your pipelines? Why do I ask you to integrate observability over there? I think the most important thing here is speed. Today, in today's world, every organization is trying to reduce time to market, and every organization is trying to be able to fix security incidents and problems within a very short time span. And this obviously has an impact on the way that you look at how do you deliver code to production. And this is very important for every organization in today's world to be able to react quickly on changing market needs and on changing demands. It can be as simple as applying a fix to an application where a button is wrong, but it can also include major security flaws that need to be protected, need to be fixed and corrected. So it is really, really important that you're able to understand the speed and the time frame to get to production. And this is not new, right? 10 years ago, the DevOps cycle started, and people talked a lot about DORA metrics. A lot of organizations, especially also Google, used the DORA metrics to actually measure the maturity of a software development and software delivery team. And I think that also the observability for your pipeline will help you to calculate most of the DORA metrics in the future. DORA metrics meaning the deployment frequency, the lead time for changes, the change failure rate, and the mean time to recover. All very important aspects of the modern deployment and delivery lifecycle especially for cloud applications. But also important, obviously, is the data that we're collecting with all of this information. Understand the delivery and deployment bottlenecks, see the impacts of changes in your application in real time. As an example, if you implement a new loop that is going to be hit by a very important portion of your application and you're doing something wrong, you might see an increase of times in the unit test cycle. You will be able to see bottlenecks, and we're going to see an example later. You can then also start to measure trends over time. What's the impact of some changes that you do? Maybe what's the impact of changing the build infrastructure as well? And also collecting this data gives you the possibility to identify problems in your build infrastructure. As an example, if you run in Jenkins and you have 2 or 3 nodes, if you have 3 nodes, one of the nodes is behaving wrong, you would see that the average time of builds on this one node is higher than on the other 2 nodes. Then you can obviously replace that node, and then that gives you insights and helps you to resolve some of the problems that you've had. So the data is really important, and it's key that we start measuring that as well. Why do we want to do that as part of the OpenTelemetry project? Because standard drives portability, right? So today, if you're an enterprise, you might have more than just one CICD tool. So you might be using GitHub Actions, you might be using code build, code pipeline, you might be using Harness for another team, and maybe the other team is still on Jenkins. Starting to work on this in an open source project like the OpenTelemetry project and defining conventions on how the different parts of a pipeline are being measured helps us to then be able to be flexible later. So you will be able to compare the efficiency of different teams, and you will also be able to actually use different vendors in the future when analyzing the data. So it's pretty important that we have standards that define for that. You don't want to have painful migrations. You want to be able to measure the same thing even if you switch from one to another CI/CD vendor in the future. So open standards and specifications are really critical for the business success, especially as vendors hold us accountable for sticking with them, right? And that means that they increase prices sometimes, and then you don't want to stay with a specific vendor and you would want to change. Last but not least, the last very important point here is obviously that we want happy engineers. And happy engineers means they understand what's going on in the application. They understand what's going on in the pipeline and what's going on in the way that the code change lands in production. Because they are able to see what happens, they're able to look at log files, metrics, and potentially also traces, and can then understand maybe how a code change that they did has impacted the results of a build. So those were the points that I believe are very important to know when you think about why do we need observability in your pipeline. And in the next part of the video, we're going to look at what the phase 1 of the OpenTelemetry SIG has achieved, and before we then look at what's next. Okay, so what has what about the SIG? The SIG got initiated already in November 2023 when Adriel, who's still our one of the SIG leaders that we have, co-chair of the SIG, and he created that pull request to propose the special interest group, and this PR got then merged in January 2024. So it's been a while since this all started, but the first important blog post around this was then announced in November 2024, right? So just like last year, and I think that's when there was more visibility on the SIG. Right, and this was the first. That was also when the first phase of the project already started, or maybe it's already kind of finished. Most of the work then has been done between November and April 2025. And what the team has been working on is trying to look at how to define semantic conventions. So before we go into what semantic conventions have been defined for CICD, let's look at what are semantic conventions in general, right? OpenTelemetry uses semantic conventions to make things comparable and unify things. In this case, it is a common set of semantic attributes which provide meaning to data when it's being collected, produced, and consumed. In the example that we see here on the screen, we're using an HTTP server semantic conventions, and we're defining what an HTTP request method is. We're defining what the URL path is in URL scheme, what the error type is, and what the method original is. And this makes this information comparable across multiple different tools and vectors, right? Because you all put them behind the same attribute. And as you know, it's really hard to define things when you have multiple software engineers coming together. If you have 5 software engineers, you will always get 10 opinions. I think in the semantic conventions for CICD, there was 30 to 40 people involved. And I think this shows how hard and difficult it was to finish that definition. So which attributes have been defined in phase 1 of the project? We have defined the CICD pipeline name, which is kind of obvious. We have also defined the pipeline result, which can be success failure, timeout, or skipped. And we have also defined the run ID. And in addition to the pipeline attributes, there have also been a definition of some deployment attributes. This means what are we actually deploying and passing through the pipeline? This is a deployment ID, a deployment name, and a deployment status. We have also defined some attributes for the version control system, which is being used in order to be able to identify some of the changes that go through the pipeline. And I think that is also kind of common sense. And also then the test attributes that are required to identify test cases that are being handled. In addition to the attributes, we have also defined some artifact attributes that are going to be used to identify an artifact. And then obviously, if you start measuring those attributes, you can start to also define metrics that are based on the pipeline. And the metrics that have been defined so far, especially the pipeline run duration and the worker count, and then also obviously the errors that are being handled, right? And then there's some additional metrics from the version control side that might be interesting, right? If you want to measure DORA metrics, you also need to, as an example, measure the time to approval, right? So this means how long did it take until the version control system, the pull request got approved in the version control system. You need to know how many repositories are involved and stuff like that. And these semantic conventions are now available and have been merged through the OpenTelemetry project. That means you can read them up as well in the semantic conventions page, and the link was at the beginning of the page. But that's not the only thing that the project achieved. The project also achieved to implement some of the receivers that are required. As an example, there is a GitHub and a GitLab receiver now open sourced that can be used to consume information that follow the semantic conventions from both the GitHub and the GitLab CICD tools that we have, so especially from the workflows component of those. And in addition to that, the SIG has also made a proposal for an environment variable propagation, right, which essentially is important if you have in a pipeline different tools that come together. There's some environment variables that need to be pushed through the pipeline as well, and this is a proposal on how this can be handled. That's are the great achievements of the SIG so far. Thank you so much for everyone that contributed to that. And we're going to look at how that now looks in an example tool, looking at a project's pipeline that I'm running as a side gig. So let's go into the next chapter. Yeah, and now let's look a little bit into the demo. So for those that are not aware, I'm building a side project which is called NEXO Share. It's a social media marketing tool that you can use to publish your content into different channels. And at the moment we support X, LinkedIn, and Blue Sky. And this one obviously has a CICD pipeline as well. So let's look at what we have so far, right? So we can look at, we're using one of many tools that you can use to actually visualize OpenTelemetry data. The one that we're using here is -0. That's a startup where Raphael and also Julia work on. Raphael, you've seen on my channel multiple times. And I've been using that to kind of, try this out, right? And visualize the data that I'm getting from GitHub. The way that I'm receiving that from GitHub right now, that is pretty simple. I'm going to show you how that looks. It is using an available exporter, right? So you can see over here, there is a GitHub action that you can use to actually export OTel data. And this is just this CICD action that I'm using. It runs after the pipeline. So it then scraps the information from the GitHub API and then inputs the information as traces into our tool. In this case, and this is an OpenTelemetry compliant tool, right? So you will see all traces coming in for all of the pipelines that are being executed. Given the timeline is at 30 days, it's going to take a few minutes now. You usually don't want to have that large data sizes over here, right? But you will see that there is one trace for each of the pipeline executions. As you can see, I had 3 pipelines executions before this one goes pushed to production, right? So you will then also see the duration of that span on the right-hand side. And that's what we're going to look at in a dashboard, because that's where it makes a little bit more sense. If you look at the deployment frequency on the left-hand side, it calculates the executions. You will see that I've deployed 65 times since I've started to capture this data. You will also see how many commits do I do per day for this project, right? So as you can see, this was, I think, a Friday where I pushed a lot. Right? I think that was pretty interesting. And then you can see that those are the commits that I get to my repository. You then also see the number of production deployments per day. You see that I've added myself a green line if I deploy twice per day, and a red line if I deploy only once per day. Anything below is obviously really bad. As you can see, I've crossed that mark a few times, and this was when I was preparing for this talk. You will also see now down here the workflow, the timeline of the workflow executions, right? And what is very interesting over here, and this is something that I also looked at in the past few days, is the deploy to AWS step, right? As you can see, there was a time period over here where it has jumped very much, right? This actually drove me into looking at what's going on, right? And at that time, what I was doing was, I was actually adding the commit ID to every single resource as a tag, which means every time that I pushed a single change, all CloudFormation stacks were updated. And that resulted in the execution time going up from 12 minutes to over 28 minutes, right? And as you can see, I quickly fixed that again after a while, right? So I think that's pretty important that you see these kind of things, right? And you can use that data, looked at it over time. This shows averages, minutes, right? Down here, you can see then also the details if you're interested in that, right? So this can now be used to drill into details, right? And as you can see, this deployment step to the AWS is currently the one that takes longest, right? But if you zoom in a little bit, you should also see that from a front-end perspective, I've been adding more front-end, more tests, so the test times increase. Now, this is not a very good project to do this analysis because, I'm not pushing daily, I'm not working on this daily, it's a side project, but still you will see a trend if there is a trend that is happening, right? And I think that's the important part that I'm looking at right now. But as you can see, there is a lot of things that you can do with that information, right? You can also directly look at the different attributes that are added over here, and you will see this follows the CICD conventions, the way that it's being sent over here, right? So you will see the semantic conventions being followed by the spans and the resources that are being added as well. So I think this is pretty cool, pretty impressive. Yeah, thank you to everyone that contributed to the SIG to make this happen, and thank you Dash0 for implementing this. And now after the demo, we are back into the slides. So we're going to look at the phase 2 of the OpenTelemetry SIG that has been announced, focused on CICD. The phase 2, and I am trying to find my PowerPoint. Phase 2 has been just announced, I think a week or two ago. It was merged end of October. So that means that we are now in the second phase of the project. What the SIG is going to look at in this next chapter of the SIG. We're going to look at the SDK, the variable context propagation, what we already kind of proposed in the phase 1. We are going to look at enhanced signal attributes and conventions. We're also going to look at stabilizing the semantic conventions for CICD from experimental to beta status to ensure that, well, they are kind of stable. And that will then hopefully also drive the adoption by other vendors, not only by receivers of the OpenTel data, but also native integration into the CICD tooling that we have, right? Like I would love GitLab, GitHub Actions, Harness, Jenkins to natively support the semantic convention so it becomes more comparable. And then as a stretch goal, we want to think about how to enable long-running traces, right? So if you have a pipeline that takes multiple hours, right, how do you really make that visible and make that usable? So a lot of things that are being worked on here, and OpenTelemetry SIG is always open for people that are contributing. First of all, let me thank people that have contributed to this. On the one side, Adriel, who has also helped me to review the slide deck. Dotan, from an AWS perspective, where I've been working with very closely as well. And last but not least, Raphael, who works for Dash0 now, and he helped me to build up some of the dashboards and get the data into Dash0. So next thing would be, how can you help to make the SIG more powerful and to introduce some changes? Well, read the blog post again. Join us on Slack. We are on the CNCF Slack in the channel OpenTel CICD. Would love to get more contributions. We have regularly calls with the special interest group, an open call where everyone can join, and we are debating about what we're working on. It's usually Tuesdays at 3 p.m. CET, so 9 a.m. Eastern. And, well, just get on GitHub, right? The link is on the QR code if you want to join. Watch the project, help to review PRs, and give comments on that. Special ask for those that are working for a vendor. If you're working for a vendor that is building CI/CD tools, please talk to us. Please reach out to the team to support the semantic conventions, get them out of the box, and make them enabled, right? And if you're building observability tools like Dash0, stuff like that, help us to build dashboards that can be shared across different organizations that measure dollar metrics, or maybe that measure other things that are important from a CI/CD perspective. And if you have CI/CD in your organization and you're using observability, OpenTelemetry observability to already measure that, please let us know, right? And obviously this can all be expanded a little bit, right? So I only showed the data from the CICD tooling, but if you now integrate the OpenTelemetry plugins for Maven, for NPM, for Flutter, and things like that, then you really make a difference, right? Because you can then also see traces and logs from the different application builds and the test executions. And this might give you a lot of insights before you actually land in a production-like environment. With that, thanks again for watching this video. I hope that you enjoyed. I hope that you learned a bit about the OpenTelemetry SIG, and I hope that I can get you involved and that you're going to contribute to this project. And if you're not able to do that, also not bad. As long as you understood that measuring and looking into your CI/CD pipelines is important, as long as you understood that from this video, I have achieved what I wanted. So thank you so much for watching, and looking forward to see you soon.